Okay, so here we have the windshield wiper program, and right now it's in stop mode. And what I'm going to do is increase it to a fast mode. And I'll slowly bring the potentiometer down to the medium mode. Bring it down further to the slow mode. And then to the intermediate mode. That's still slow. There's your intermediate mode. Waits 3 seconds. Waits 3 seconds. Waits 3 seconds. And of course, stop mode returns it back. Now, no matter where I am, if I put it in the stop mode, it will always return to the robot's right and stop. Here we have the Fritzing schematic and breadboard for the windshield wiper build and programming challenge. All the parts here are either from VEX or from the Arduino 101 kits from SparkFun Electronics. Here we have the Arduino 101 board, which is tied into the motor control board, which controls this motor. The potentiometer is going to give feedback to the Arduino 101 board. They will control the speed of the motor. And here we have 2 limit switches or momentary contact switches, depending on what you have. And these are normally closed, so I need a 1000 ohm resistor. And when they're hit, then they will become open. So what you see here is the windshield wiper program that I put my students on. It's a challenge to create a windshield wiper program by using any sensors that they wanted: motors, servos, potentiometers, optical shaft encoders. They wanted limit switches. They were not limited by anything but their own creativity. And the windshield wiper program should follow a simple stop, intermediate, slow, medium, and fast modes. And again, they could program it any way they wanted. This is my example for my students, and I'm using an if, else programming. And following this program, I show my students another way of doing it with while loops and breaks. I am using this for my electrical engineering class, an honors class at the high school level. And we are using SparkFun 101 kits. And this program that I'm setting up uses 3 of the experiments that are set up in the 101 program that they have. So this is experiment 2, which is the potentiometer, experiment 5, and experiment 13. 5 is push button, and 13 is motor control by potentiometer. I am also using the bounces and timers. So, simple setup. What we're going to do here is set up our direction, our PWM. We're setting up our, here's our to bounce unsigned char. I'm choosing unsigned char because I think using integer is cheating when you use it all the time. And again, I'm going to use a timer, so I need 2 variables with unsigned long, old time and current time. I'm going to set up my serial begin, and then I'm going to set up my pin modes. In the beginning of my loop, I will create an integer called pot and analog read it. And here I'm creating two unsigned characters, one for my left limit switch and one for my right limit switch. And of course, I'm printing all of that. Now, I would go right into the stop and the intermediate statements, but those are the two hardest ones. Let me just go show you the slow, and we'll come back to those two. So here we go. Here is the slow loop. It's an else if. So if else if pot is greater than or equal to 400 and pot is greater than 612, slow loop. Come in, print that you're in the slow loop, and print your debounce. If left limit switch is hit, come in and stop the motor. Select your debounce to equal 1. Now this is important because if select is equal to 1, I am going to change the direction of the motor and set the motor to a slow speed, which in this case is 40. Now, perfect. Copy and paste that directly below, and what you'll see is this statement is exactly the same as the other, except we're changing it to right limit switch. Of course, we stop the motor, and we're changing the select to 2. If select is equal to 2, we again then change the direction. The last one was direction A was high, direction B was low. Here we're changing that to go the opposite direction. And again, my speed is set to 40 PCK. The next else if statement is for the medium loop. What is exactly the same as the top loop we just did, the slow loop, except for the fact that when we come down, I'm going to change the PWM speed. That's it. That PWM speed is going to be a little faster, and that's going to be 50. And of course, same thing, 50 for the opposite direction. Then we have our last statement, which is else. So we have if else, else. And our print, and the last one was slow, and then the medium, and then now we're going to print fast, and where we are. And again, same thing happens, except we are going to change the PWM to 70, the fastest speed. And again, the same thing down on the right side, we're setting it to 70. Now, the hard part for this is the stop and the intermediate. The reason why the stop is hard is I do not want the stop to happen if the left limit switch is hit. I want it to stop when the right limit switch is hit. So it always returns to the robot's right. So again, we're going to print stop mode. We're going to come down. If left is hit, we're going to select 0. Select is going to be changed to 1. If select is 1, we're going to change the direction, and we're going to set the PWM to 40. That's the very slow speed. Now, we had an issue right here. If this if statement right here is to, if the arm was heading to the left side, but the left limit switch wasn't hit yet. It was a stuttering effect. So what we did was fix that. So if left limit is not hit and right limit is not hit, and select is not equal 1, we're going to come in here and set select to equal 2. Change the direction, and again, keep the speed going. Here, if right limit switch is hit, meaning low, select is equal to 3. If select is equal to 3, we're going to stop our PWM. Perfect. So that was the if statement. The next one is our else if statement. So here, if I fall between these two numbers, I'm going to come in and print that I'm in the integer. I'll print my select. If left is hit, I'm going to stop the motor, and I'm going to select my debounce to equal 1. And if it's equal to 1, it's going to change the direction and set PWM to slow. pretty much the same thing as the stop loop, because I want the pause to happen on the right side. So if the left is hit, or if it's going left and I fall in here, I want it to pause only when it's on the right side. So here, if right is hit, it's going to come and stop the motor. It's going to reset the time. Old time is equal to current time. I'm going to set select to 2. If select is equal to 2 and current time minus old time is less than 3 seconds, I'm going to come in and pause. Set the PWM to 0. Set both limit switches to read 1. And I'm going to serial print pause. And again, at the last part, I need to now else if select is equal to 2 and current time minus old time is greater than 3,000, meaning that you are higher than 3,000. I'm going to come in and select is equal to 3, and I'm going to print reset. If select is equal to 3, I'm going to change the direction of the motor and set the PWM to 40. And that is it. And I can show you that. So what we're going to do here is I'm in the stop mode. And as I increase the potentiometer, you see the pot's going up. I'm printing the select, I'm printing my left limit switch, I'm printing my right limit switch. And right now it's in the stop mode, so the right limit switch is reading that it's hit 0. As I increase, I'm going to go into the integer. And then I go up, I'm going to slow mode. And I go up, it's going to go to medium mode and then fast mode. I can bring it down, fast, medium, slow, integer, intermediate, and you can see that it's printing the pause. And that's it. Okay, and what you'll notice at the end of my program, which I've commented out, is where I'm doing it now with while loops and breaks. The only difference is that when you do the while pot is greater than 204, so I'm changing that if statement to a pot, is I'm printing everything that I want inside that loop. And then I'm coming down, and at the very end, I'm stuck in that loop unless I can get out. And therefore, what I need is an if statement. And if pot is greater than 204, meaning it's the exact opposite of what the while statement is saying, I will then break. And the break kicks me out of this while loop. Again, I'll show you that again. While pot is between these two numbers, come in, print everything that I want. Then everything else is the same. Right? The only difference is the very end. I need to have an if statement that says if pot is greater than 204 or pot is greater than 408, meaning the exact opposite of what the while statement is saying. When that is opposite, I'm going to break, which will then kick me out of the statement. And again, it's nice to use an or statement. Again, here, while pot is greater than or equal to 408 and pot is less than 612, slow loop, come in, print everything you want, and then at the bottom, you're going to have an if statement with that same break. Here we go. If pot is less than 612 or pot is greater than 816, the exact opposite of what I said in the while statement, come in and break, and it kicks you out.